You have $40 in the bank, you save $6 per month, and you will save until you have $124. So I want you to write a linear equation for the amount, a linear equation of the amount of money A you have as a function of time T in months. So just to think of some points here. So let's make a table of graphs, a table of points that kind of, this might spark some intuition. At time 0, right now, okay, well, let's say to start, you have, well, here it is, $40. But every month, you're going to save $6. So at time 1, so after 1 month, you'll have 46. And after 2 months, you will have 52. And we can keep going here, but let's think forward a little bit. At what point will we have $124? Well, this amount right here has changed by $84. Let me put that one a little bit closer here. So if we go from $40 to $124, this has gone up by $84. How much would this have gone up by? Well, you can kind of back this out, or you could work out every single point, but this will have gone, if this has gone up by $84, our time should have gone up by 84. 84 divided by 4. Divided by 6. My bad. Divided by 6. Because every day it goes up by $6. So how much is this? This is 14. So at time 14, or t equals 14, or 14 months, is when we have $124. So if we graph this function, so that's what I first want to do. Let's graph it. And to think about which label should go where, our amount A is a function of t time. We could do it the other way. We could say that area or time is a function of A, because it would just flip these axes. But mostly we want to see our amount, the amount of money rising over time. I mean, we will ask a question at what time does the area equal something, an area, the amount equal to something, but otherwise usually this is probably the best way to look at it. Okay, so graph the function. So here we have some points, 0, 1, 2. So how much do we have at 0? We have 40. And at 2 we have 46. And my pen is not fine enough to get all of this in here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make the graph a little bit bigger. 11, 12, all the way up at time 12 to 124. And then we stop, right? We also wouldn't connect these points because these are discrete. Just like it doesn't make sense to think about having a fraction of a week, a fraction of a month. I did not say that we would get any money halfway through the week. So so this would be a discrete graph. That's gonna play into other questions later. Show on the graph the point you have $120. So here's $100. And at what time will that be? That will be at t equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right about there. and you can find this point 10, this point 100, 10, 100. You can find it by extending this or doing something similar here. Let's do that. So if we went here, I'm just going to write part of this table of values. I want to know when this goes up to 100. Well, it's gone up by $60. How much time does it take to go up by $60? It takes 10 periods. Okay. Extension, what are the domain and range of the function? Well, let me just keep the rest of the dots in here. The domain is what can go in. So let me write domain and underline in. How do we describe this domain? We describe it as all of these points. 1, 2, 3, 4, 5, all the way up to 12. I mean, I say 12? 14. Right? These are the x's, or the t's, or the independent variables that can go into this function. Oh, and we didn't write the function here. Well, I didn't ask. Well, I guess I asked for up here. Write the function. So let's write the function. Move this down. Let's grab this. This is a is a function of time. I'll write it as a. A is equal to, well, we start with $40. Every period we go up 6. So this function right here describes this table of values. I hope this I hope that's intuitive. This is the also 6 happens is in terms of definitions is the change in A divided by the change in T, which is our slope formula, which usually we think about change in Y over change in X, but these axes are labeled A and T. So how much does A change? A changes 6, right? You can see it right there, 40 to 46, or any of these points, 40 to 46, every time changes by 1. Okay, I don't know how much time I have. But generalize the, okay, so we wrote the function, we graphed it, be sure to label your axes, show on the graph the point 100, what are the domain and range? The domain is 1 through 14, because that's what can go into this function. It doesn't make sense to think about half weeks or fractions, decimals of weeks, just these whole numbers. And the range is what can come out. The range is 40, 46, ... which means all the way up to 124. So generalize, you start with Z in the bank. So let's move this up. You start with Z in the bank, and you save W per month. Write an equation for A in terms of Z and W. Well, here we go. A is equal to, remember, here we go, we start with Z in the bank. Let me underline that orange. We start with Z in the bank. Well, that was just our $40. So here we're starting with Z, and we save W per month. Well, before that was just 6, and here it is 6. So let me get this in orange. And that would be plus WT. So there you go. Okay, I hope that was helpful.